In this video, you're going to see how the product and sum to product formulas help us verify identities. So remember, these are your formulas that you're going to need, so we're going to keep them handy for our verifying, and you're going to see real quick how they're helpful. Okay, so we see in the numerator and the denominator, we see different values for the input on the right-hand side, the 3x, the 3x, the x, the x. We need everything to be x and try to simplify this all the way to tangent. So we have different formulas like sum and difference, as well as double angle that can help us break down that 3x. But what's really cool about the product to sum and sum to product is we actually can use that to create a product in the numerator and the denominator. Because remember, if we have a product like a times b over c times b, we can cancel if we have a product. And that's our big goal here. If we can cancel, maybe we'll just come up with tangent of x. So we're going to see how we can change this using the formulas that we have over here. So we're going to change the sum in the numerator to a product according to this formula, because I have a difference of two signs. So I see that my alpha is going to be 3x and my beta is going to be x in the numerator. So I'm going to use the formula and write the top as 2 sine of, it looks like I need to subtract alpha minus beta and divide it by 2. It looks like I also need to multiply that by the cosine of alpha plus beta, so 3x plus x divided by 2. I'm going to simplify this out before I officially replace it, because I think that's going to help me just keep it clean and not make any errors. So it looks like I'm going to have 2x over 2, and then cosine, it looks like I'll have 4x over 2, and both of those will simplify. So my numerator becomes pretty simple, sine of x, 2 sine of x cosine of 2x. So I've been able to break it down from 3x down into 2x. If I have to go further, I know how to do that. But I'm going to start by just changing that top part to 2 sine of x cosine 2x. That is equivalent according to the sum to product formula. Now I'm going to do something similar in the denominator. I'm going to take the denominator. Let's get all this stuff out of the way. I'm going to take the denominator and I'm going to break it down the same way. I'm going to once again find the right formula that helps me solve this problem. So I have a sum of 2 cosines. So it looks like I'm going to use this formula, with alpha being 3x and beta being x. So I'm going to use the formula 2 cosine of alpha plus beta over 2, and then cosine of alpha minus beta, so 3x minus x over 2. Let's simplify that out just like we did in the numerator. Looks like we get 4x over 2. Or in the other one, it looks like it's going to be 2x over 2. So once again, this simplifies and condenses quite nicely. I'm going to have 2 cosine of 2x and cosine of x. So the denominator will become 2 cosine 2x and cosine of x. I'm already seeing how this is going to be helpful to me. So I've only used the sum and difference formulas to change, sum to product formulas to change these guys to a product. This helps me tremendously because now I can simplify. Those will cancel, as will the 2's. And look what we've got left, sine over cosine. So all of this hard work gave me my final result of sine over cosine, which is equal to tangent. So I am done with this identity by just using the sum to product and then one more identity. So this is something that is going to be helpful, especially if you notice commonalities between the numerator and the denominator. They both have the 3x and the x. This is somewhere you want to give it a shot and try this method instead of using sum and difference formulas that make everything quite messy. So let's take a look at example 7. So we have something similar. Once again, notice the similarities. We have 3x and 3x, and we have x and x. So if we use the sum and difference formulas, the product to sum to product formulas, we'll have similar alphas and betas, and we might end up being able to cancel again. Okay, keep in mind our goal actually is tangent of 2x. So let's give this a shot, see if it helps us. So we have the sine of 3x minus the sine of x. So we have a difference of signs. So we're going to use the difference formula and rewrite the sine of 3x minus the sine of x as 2 times the sine of the difference of the two, so 3x minus x all over 2, and then the cosine of the sum of them, so 3x plus x over 2. Okay, so I used alpha was 3x and beta was x. And then we'll simplify it out. 2 sine of 2x over 2 cosine 4x over 2, which we'll rewrite the top as it'll be 2 sine of x times cosine of 2x. Okay, so that's the numerator. We're going to do something similar, of course, with the denominator. We're going to take the denominator and use the sum and difference formula. This time alpha is x and beta is 3x, and we're working with the difference formula. Take notice of that -2, that's unique to this formula. Every other one has a +2. So we're going to start this with -2 sine of the sum of the angles, x plus 3x over 2, times the sine of alpha minus beta, so x minus 3x over 2. Okay, so this simplifies to -2 sine of, let's see, we'll have 4x over 2, and the sine of -2x over 2. -2 sine of 2x, and then the sine of -x. Okay, so there's one thing that I'm not liking about this. I don't like that -x. So once again, I'm going to use my even-odd formulas, and the even-odd formula states that if I have the sine of a negative angle, it equals the negative sine of the angle, the positive angle. So I'm going to take that negative out, and it does come out in front of the sine. So that's going to change to a plus, and then I'm going to change this to a plus because I'm going to pull the negative out, and they'll cancel each other. So my denominator is going to be 2 sine of 2x sine of x. And it looks like, once again, I'm going to have some nice simplifying that I can do right away. Let's get this out of the way. So we're going to be able to cancel our 2's. We have a sine on top and bottom. And it looks like we're left with cosine of 2x over sine of 2x. Well, we know that the tangent of 2x is sine of 2x over cosine of 2x. So if we want to do the reciprocal, it will equal cosine of 2x over sine of 2x. So we've essentially met in the middle because we changed tangent over to this, and we had the right-hand side changed to that. So we have verified this identity. So these sum to product and product to sum look complicated, but they can be super handy to allow you to change things to products really quickly. That's going to be extremely helpful to change things to products when we have fractions involved. At this point, give it a shot on your own. See if you can create, by using those formulas, if you can figure out what you can cancel to create the following, to verify the following identities. So these are all multipliers, so cosine 3x minus cosine x over sine 3x plus sine x equals tangent of x. And then the other one, cosine 4x minus cosine 2x over sine 2x minus sine 4x. So give this a shot. See if you can come up with these identities, if you can properly work with the fractions and the formulas. Keep in mind the negative on that cosine 8 alpha minus cosine beta that you see over here. So keep that in mind so you don't forget about that part. Otherwise, good luck in bringing your questions to class.